Hi, today I am going to present a topic from kinematic that is important from perspective of JEE and NEET, that is projectile motion. So what is a projectile motion? So suppose when we throw an object giving it some initial velocity and it will travel under the influence of gravity. So that motion is called projectile motion. So let's say suppose we are having some object A, we are given some initial velocity u and it's making angle theta with horizontal. So it will follow a path like this. So this motion is projectile motion. So basically what is projectile motion? We have to provide some initial velocity, and that object moves under the gravity. But now you can say that this is, if we throw an object upward and with some initial velocity u, it will come again. So this can be also a projectile motion, but isn't, because it's a one dimensional motion. So there is projectile motion is two dimensional motion. So this is, yeah, it's motion under gravity, and but it's not a projectile motion. So projectile motion should be a two dimensional motion. And one thing for pure projectile in physics, we neglect air resistance. So simple basic definition means when our object with the given some initial velocity travel under the influence of gravity will follow a path that is projectile motion, and that object is projectile. So this, you can see, this is a parabolic path and there are other. So this is when we throw an object completely horizontally, so it will follow a path like this. So this is also example of type of projectile motion. So we are in first part, we are given some velocity with angle to the horizontal. So this is angular projectile motion, and this is horizontal. We are given velocity in horizontal direction, but it's making angle theta with horizontal. So this is angular projectile motion and this is horizontal projectile motion. And after we will see many example like in these two, like we will study this motion that is incline, that is called incline projectile motion. So first, as you can see in these both example, that path followed is, we can see this is a parabolic in nature and this is also parabolic in nature. So every path of projectile is parabolic in nature. We can write it here parabolic path. So first I will give you the reason or explanation why this is a parabolic. So for that we have to find its trajectory or equation of path. So let's say after some time it will be here, and you know it's a two-dimensional motion and we are having some initial velocity u. So with help of vector calculation, so we can divide this u into two components. This will be u cos theta, this will be u sin theta. So we can write our u as u cos theta I cap plus u sin theta j cap. So this is horizontal component of velocity in x direction and this is vertical component of velocity. And we know our motion is under gravity. So we are having only acceleration in this direction, that is acceleration due to gravity. So we are having acceleration in y, that is minus c. We are taking this as positive. We can take anything as positive, but we have to stick to that. So, and we know that velocity will change when there is a acceleration or deceleration in that particular direction. So but we are having only acceleration due to gravity in only y-axis, but there is no acceleration in x, so ax will be 0, and because there is no acceleration in x direction, So that component of velocity in x direction will remain constant throughout the motion until there is no acceleration provided. But in some example they may give some question like this. Suppose you throw some positive, or let's say charge particle, and you apply some electric field here, so then we have to consider acceleration in x direction also. But here in simple cases we won't consider that, so it can also be an example. So here we are not having any acceleration in x direction. So let's find this trajectory equation. So we are having equation of motion that is s is equal to ut plus half at square, v is equal to u plus at, v square is equal to u square plus 2as. So we will use these equation of motion in two different directions. This is x and y. So if we will use in x direction, so final minus initial. So our object is here, it is x and this is y. Okay, so final minus initial at ux t plus half ax t square. So ax is 0, we know that ax is 0. So what will we get? T is equal to, t equal to ux, and that ux is x upon u cos theta. So we are get t value as x upon u cos theta. So for trajectory we have to find a relation between x and y, that is equation of path. So we found t with relation of t with x. So again solving this equation of motion in y direction, that is y minus 0 uyt plus half ay t square. Sorry, this will be half g, putting value of t, that is x u cos theta square u sin theta u x upon u cos theta, that is y. So this is equation. So I should write it here. So equation of trajectory will be, by simplifying, this will be x tan theta minus half g x upon u cos theta to the power whole square. So here you can see this relation y equal to their x square, and this relation gives you parabolic nature, because the basic of parabola is something like that, ax minus bx square. So this shows our path of every projectile motion will be a parabolic in nature. So it can be, so you know, basic parabola like these. So this is parabolic in nature. Now we have to find other components like perimeter. So we have to find total time of flight, t, range, and maximum height. So I can take any kind of that projectile motion, but it's general, so you can, it is easy to derive from here. So I am taking this as an example. So first we have to find time period. For time period we are going to solve, for these three we are going to solve same equation of motion in x-axis and y-axis separately. For time period we know total displacement in y-axis is 0. So so this is, I have to write half g x upon, so this is equation of trajectory. So for time period I have to find in x y direction. So total displacement in y should be 0 minus 0, that u by t plus half a by t square. So taking this to other side, uy is u sin theta, 1 t got cancelled, half of g t square, 1 t will be get cancelled. So time period will be u sin theta 2 u sin theta upon g. So this will be time period for our entire projectile motion. For range we have, what is range? Range is this distance traveled, so that is ux into t, means horizontal velocity component into total time taken by the projectile, time of flight. And we can see that this is x or range, and this comes from first equation of motion, that is uxt plus half axt square. Ax is 0, so this is simply, so what is ux? This is ux, this is uy. So ux is u cos theta, and t we are having 2u sin theta upon g. So then what will be our value of x? That is range. Range is u square, and what is sin 2 sin theta cos theta is sin 2 theta upon g. So this is our x. Now we have to find this maximum height. So for maximum height, what we have to do? We are having third equation of motion. So let me rub this one. So we are having third, we can use, one of equation of motion, that is u square v square minus u square plus 2as. So we are solving it for y axis, uy, ay. So s is here our h, maximum height. So you can see when the particle reaches here, there is a maximum height, and then our horizontal component will be remain constant, and this vertical component will be 0 here. So putting into this equation, 0 equal to u cos theta whole square was, sorry. So this is, initially it's u sin theta. So this is u sin theta plus 2 minus g, and s is h. So then h will be u sin theta to the power whole square upon 2g. That is height, maximum height. So this is our maximum height. So I am writing this here, whole equation. So time period will be 2u sin theta upon g. Range will be u square sin 2 theta upon g, and h maximum will be u sin theta square upon 2g. So these we are having all the required equation for time of flight, range, and maximum height for our parabolic. So here we all know how to maximize in any quantity. So if we maximize range with respect to theta at maxima, at what angle it will give a maximum range? So we will find, after solving this, theta is equal to 45. So at when theta is 45, it will be give maximum range. So if you put theta here, so r maximum will be u square by r. So it will be independent of theta. So, and one other thing, if our motion is like this incline, so it can be incline also. So then we have, what we have to do to find this t, r, and h? So we have to change the axis, x here to here, and then we know that g is downward, and this angle will be, this is 90 minus alpha. So this will be g cos alpha, and this g sin alpha. So then ay will be g cos alpha, and ax will be minus g sin alpha. So we have to take ax is equal to minus g sin alpha, and ay is equal to g cos alpha to solve this equation. So this type of projectile motion, that is inclined motion. So this is how we are going to solve this, and we have to take ux is equal to u cos beta, let's say this is beta, and uy is equal to u cos beta or sin beta, sorry. So this is how we are solving this equation, and I told you where is the maximum r when theta will be 45. One thing I want to add there is that if we are having theta is equal to, let's say 30, and theta is equal to 60, we will get same r value. You can check by this, and for this our u should be same. So then for theta we will get theta, and 90 minus theta we will get same range. So it will be look like this. We can check here by putting into formula. So r is u square sin 2. If I put 90 minus theta here, so I said theta 90 90 minus theta will have same r value. So if you put